Hi, I'm Marcus Nagy.
And I'm Delio Milese.
This is our Engineering 359 microcomputing project. For this project, we wanted to introduce safety features with a homemade brush DC motor. Concepts from our electromechanical and microcomputing class were used. In this project, we wanted to use temperature and ultrasonic sensors to shut off the motor. Some of the parameters for temperature was above 30 degrees, it would shut off, or within 6 centimeters of the motor, it will shut off.
We used variable components to complete this project. One component we used was the Tiva L298 dual H-bridge motor controller. This varied the amount of voltage that would be supplied to the motor, turning it on and off. We also used the Tiva C-Series TM4C. This microcontroller took the inputs from our sensors and determined whether you should turn the motor on and off. We also used the Tiva sensor hub attached with the TMP 4000 temperature sensor, which calculated temperature using infrared sensing. We also used an Arduino ultrasonic sensor to determine distance. The software used for this project was Code Composing Studios, and we also used a universal asynchronous receiver transmitter to display real-time temperature in Celsius and distance in centimeters on our display of our computers.
Moving on to the DC motor, we built this motor with 4 coils. Each coil has 160 turns, with 2 magnets stacked on top of each other below. The motor itself runs on a 27 DC power supply and is programmed to turn off either after a temperature of 30 degrees is reached or if an object comes within 6 centimeters of the moving components. For those of you who don't know about DC motors, we begin by applying a voltage on both sides of the coil. Because there is current flow in a conductor in a magnetic field, there will be a force on the conductors, the direction of which can be determined from the left-hand motor rule. Oh, there we go. Here you go. You do it now? Go down.
What's up, dude?
I'm now going to talk a little bit about the temperature sensor. The values are read in binary to the Tiva through the infrared sensor. A clock cycle is combined with the reading to get up-to-date values every few milliseconds. These values are then converted to Celsius. A conditional statement is then added with the clock cycle to write out a value to pin 4 on port F, which is connected to the MOSFET gate. This will turn the motor on and off accordingly.
For the ultrasonic sensor, a pulse is sent out through the trigger of the sensor and later brought back by an echo. This is returned to the sensor and the distance is calculated for how far the objects are. Similar to the temperature sensor, it is hooked up to a clock cycle and a conditional statement is then written to the motor to turn it on and off.
As you can see in our video, we did not use the motor controller. This is because the diode from the 5-volt enable on the motor controller was shorted due to a large amount of current from the high DC supply. Instead of a motor controller, we used 2 N-channel MOSFETs. The reason we used 2 was for protection of the Tiva board and computer from high DC current spikes. The schematics are as shown. For a reference to our code, we've also attached a link below.
Victory!